Hey guys, after a bit of time, we are back with some uh, different approach to this YouTube channel, and going forward, will be what we're going to do is instead of doing tutorials and all, um, because given the rise of LLMs, everything can be just, um, you know, you can just query the LLM and get whatever you want. Even they are capable of teaching you tutorials and anything you need. So I don't think YouTube tutorials are very relevant right now. So the only thing that I had in my mind to do is to do some recreational programming. What that means is programming for recreational purposes, which is just for fun. And I just want to code something, I just code it. Whether it is hard or whether it is easy, it's just for fun. And in this vibe coded and all this stuff going on, I think handwritten code is what is missing nowadays. And there are few rules here. And the first and the most important is this: we are not going to use any AI tools to write code. Then we are not going to use any agents to write code. Everything is going to be handwritten, and this makes us think that um, you know there was a world without AI agents as well. So yeah, so that's the goal of this channel going forward. I hope you like it. Um, so in this video, we are actually going to be writing a JSON parser from scratch. So the goal is so I thought of this because of this repo, Kwan from Knath, Kailash Nath. He's actually a great guy. And what this does is you can just load your JSON, or you can just give the path of your JSON, and it parses it, and you can query the you can query it like this, like the key dot another key, and you get the value. So this is quite easy for the user to query the JSON keys. So we'll be building this, and if we have time, if I have time, then I also want to build this watch feature where I want to see if the file has changed. So because if you change the file, we need to reload the keys, and we need to build it again. So if you have time, I'll just build. We'll just try this as well. I haven't written any code beforehand. It's all going to be live on record. So yeah, I think let's get started. For this, we are going to use Golang as usual. For that, I think go slash src and we'll create a JSON parser. I'll just init this. So right now we have we do yeah, right now we have this go mode. We'll just add a main.go here and let me open tx extra. Okay, so let's write some boilerplate. um yes, just try, let's just do hi to see if it works. Open a new tab. Okay, I need to increase my font. It works. So okay, let's have a mock folder, because in this we have a data.json which we want to load and query upon. So this is going to be JSON, and let's say we have a name, we have country is India, and let's have a nested JSON as well. Yes, let's say YouTube, video count say 50, I guess. Don't know how much. Total views, let's say, that's quite low, but I think we can still have videos. And that we have the first video is as a title one, created at, let's say I created this on 0503 6. I think this should be good enough for us to get started. So with this data, um, first let's try to load this into memory. So Golang now actually has a parser inbuilt. So if I do JSON dot unmarshal, right? You can just unmarshal the JSON into whatever variable we want to give. So if we see this, it takes a byte and the variable which we want to copy this to store in memory. So this byte is a JSON in bytes. For that, we need to read the file. So let's read the file in mock slash data.json. We get the data, say JSON data in bytes and the error. And we need to handle the error. So if there is some error, we'll just stop here. Just say we're reading mock slash data.json. And I think here we can give JSON in bytes, data in bytes. For the I think so. Usually, what we do is we give a struct, like we create a struct and we give the struct variable here so that exactly maps to that struct variable. So, for example, we have a, let's say it's z and a struct. We can have a name field which is a string and which has a JSON field of which it goes like this. Name something. So if you do this, when we map this and when we unmarshal this, it just the name gets populated here. But in this case, we don't know how the JSON is going to look like. Also, we need to create a map. So this entire JSON gets stored in a map. So let's just create a map. String and any is the value because we don't know what the type is. So when we're printing hi, let's print m. Should pass the pointer because we are changing m, so we need a pointer. Again, we need to handle this. If we try to run this, you see the map gets populated here. And the reason we gave the any as a value and string as a key is JSON always has a string as a key, but the value it's going to be anything. Like here it's integer, here it's string, here it's another JSON. We don't know what it is, so we just give any. So now the problem is how do we query this? Because just the map doesn't show any hierarchy. It just has the keys and values. So we need to parse this and store this in such a way so that when the user queries this, we get something we should be able to query it in a hierarchical way. I think I'll just create another file here instead of main. I'll just say parser.go. Let's move every parser thing there. If I go here, package main and have a parser struct because we need to have methods which are tied to this struct. You can say I think we need a parse method for now, and this parser will have JSON map this map string any. We'll have a new parser returns a parser. And the JSON map is going to be this. Just make it. Otherwise, we get a map is nil exception. So we need to make it in order to use it afterwards. I think we also need the JSON data in bytes, right? So it's byte. Um, do we pass it here or let's just take the path here? JSON path. And whatever we did here, we want to do that here. After doing this, I think we can say this JSON data in bytes. What else is there? Like this. As for parsing, I think we need to do this. What are we returning from parsing is also does matter. So let me create this thing. JSON map. Um, we return error or we can just return the. So the parse script, the parse populates this actually. So what we can do is P is going to be new parser. The JSON path is this, and we can say p dot parse, and then we can print p dot JSON map. New parser is undefined. Is it undefined? Okay, because if we do go run main.q, it only compiles the main file. We need to build it and then run this like this. Yeah. So this works. Um, but still the problem is we will not be able to query until we have some structure. So right now we have a map which is populated with the JSON things, JSON keys and values. So what I'm thinking is we could have some tree kind of thing, because the first thing that comes to my mind is when I see this JSON is uh, it's more like a n array tree, isn't it? Because there's a root node here and there are n other nodes as children. So this is a root node and every key is a child here, right? And then these, for example, this has a value here, this has a value here, this might have some more children here, this, right? So when this will be easy to query, because if I say this is a, this is b, this is c, d, e, f and g, for example. So if I want to query, let's say a dot d dot g or f, a dot d dot f, then we will go from here. Then we see if a has any child called d, then we go here, and then we again search for a child called f when we go there. So then we can return the value of this node back, which is a value the user is searching for. So if you are able to build this kind of structure from whatever we have now, which is a map, then I think it would be much easier. For that, we just don't want to pass. I think parsing is fine. We are just parsing it and populating the map. But more than that, we need to build a tree and store it as well. Let's, I think let's create another file called tree.co. Package would be main. So similar to this, so instead of having a struct called a tree, we'll just have a struct called node, which will have key value, and children will be a list of um, pointer nodes again. This is similar to how people do in DSA, right? If you want to do a in-order traversal to a tree, but there it's usually two branch tree, right? Usually, here it's an n branch tree. We don't know how many children we have. So if I do node struct, the key is going to be a string always. The value is going to be any, and the children, we are going to have, this is the list of node pointers which point to the next another node. We could have a parent which is a node, or just a string at least. Um, so if I say new node, right? So this should return a new node. I could take a key value could do this. Um, can I do this? No, there's no parameter overriding or something. Okay, I think we create a new node. So this we are going to have a function called build. So we are going to build, and then we might also have a query function. The query is the last part. The first part is going to be build. What this returns is, let's see. So when we are parsing this, let's go to parser. When we are parsing this, right? Let's take this. We might handle this later. So if after populating the map, we need to build the tree, right? Um, we need to build a tree. We'll call the okay. We need to create a new node in order to build it. Let's create in so the root node. I think we'll just create a new node without any key string, and then we can say root node dot build. Um, what I'm thinking is let's anyhow we are going to use recursion here. Um, so the thing is how are we going to do that? Let's say we start from a root node, right? Let's take root as argument. We could do the n might be the root node, but we don't want to modify that. So let's take root node as this thing. So if root is nil, we will return. We don't want to go forward. And so the thing is we want to build upon the root node. So what that means is build upon in the sense we need to have children which are new nodes. So we need to create a new node for each key and value we see. So for that, I think we need to have the JSON, right? So let's say J is any because we need to know which part of the JSON we are in. So you can we don't have access to the JSON here because that's in parser. So we need the JSON, and we need it as an argument because we'll be sending, for example, here for this nested thing, we'll be sending this recursively again as J. So that will be considered as a JSON in that context. Let's try. I don't know if that works, but um, so now what I want to do is I want to check the value of I want to for each key and value in let's try doing that range of J, and I want to do this. So I anyhow this is going to be a map, right? We are going to be sending it as a map, and for each key and value here, so this is going to be key and value. What I'm going to do is I'm going to see the check the value of v, not the value, the type of v, and if that is another map, I want to do something, or if it's not, I want to do something. So so let's go with if it's a string, right? Then we want to create a new node here. I think we need to create a new node and add it as a children to the root, children to the root. Yeah. Um. So how do I do that? I think I can do new node is new node, and new node dot p will be k, new node dot value will be v, and new node has it children. How do they have the children? Right now I don't think they need any children, but we need to append that to root's children. So here we can just return, we return null, because in this case, so now I think it should work for, let's try building it. Let's see if this actually compiles without errors. The build needs the root node, and j is going to be p dot json map. Okay, where are we printing something? I don't want to print this. It compiles, but let's print the root node dot children, I guess. Yeah, we have two children. That's because we are considered these two key value pairs. We are ignoring this because the type of this is map. So let's try handling that, or should we? Let's try actually handling that. So now this is a complicated case because this is a nested thing we were talking about. So anyhow, we need to create a new node here, which we are going to uh, create, and we need to call this build recursively. I know that for sure. So if I call dot build, the root is going to be hmm, what is the root going to be? Is it the same root or okay? I think the root is going to be the new node, right? And the j is going to be v because the value it's that's what we're going to say. So this is the node, right? So new node dot p. I think it should be a, I guess. The value is going to be v. Let's, for example, let's say that. So after doing that, we create this. Then we say same goes here. So for this node, right? If you see this, we have this key value pairs. Just thinking, how do I? What am I missing here? Because we're going to recursively go and with these new values, we're going to. I doubt it should we send the new node here because this has no connection with anyone anyhow. If I send root here, right? I can do node here. Okay, that's type any, right? Maybe what do I need to do? So I go again with the root, but why do we even need the root if we are just happening to the same root, right? So let's create a new node um, with the keys and values of root. This should be good. The value is root's value, and but how does this work? The new node dot value is going to be node dot value. That is, we're getting any here. Should I convert it to node then? Oh, that's not node. Right? Um, how a lot of nodes, but not because I think we need to print this and walk and print this. Let's create a walk with the root node. So again, if root is nil, we're going to say return, or else for each child in root dot children, we're going to be printing the child's key first, child's value, and then I'm just going to call walk. I could call can be done another, but I think just see what going. Root node dot walk of root node. Um, we have name, country, video count, total views, but that should come as the videos. I think that's fine. But I think the YouTube part, it's nil here, but these both should come under YouTube as a map, right? I think I'm not doing that part here. What if I do root dot value? Then there will be no. What if I do this and then just do return? The same. Yeah, I think now I'm getting the YouTube and the videos part as a map. Um, yeah, I think that's good. So what happens if I add another query here. Let's say title 2 and it's added today. So yeah, I think that it's map of a list of maps. Oh, that's fine as well. So if I want to search for um, this one, this title, right? Then I have to do YouTube dot videos of zero dot title, right? That should be it. So let's this is good. I think we can add a feature to query this. Um, but before that, I want to fix this. I don't want this to be tied to the new node, the node, because you're not using that anyway here. So I'll just remove this. I can just remove this. Or the other way is that um, I can remove the node here, and but still that doesn't work. Let's just remove this, and here we can just say build, but I'll just rename that to build 3. It's in the root node and the JSON map. And the walk as well, I want to remove this because n is null, and we can just do dot walk, not n dot walk, it's child dot walk. Yeah, we have to change that here. You can just say root node dot walk. Yeah, that works. But where do we get the video count and total views as separate? Okay, I think it's going inside. I think that's fine. Um, let's finish the to do. This is fine. Um, so for querying, I think we need a query here, which is going to be a string, because the way I'm going to query it is that I'm just going to say, I think we need to store the node JSON root node. So we'll just say that after building the tree, I'm going to say p dot JSON map root node is going to be the root node, and I'm going to use that here by saying p dot JSON map root node dot query with this thing. I think this should return any. So we'll just return this. I don't know if we can return the error. Do we even need to return the error? For now, let's just return any. So this is very much similar to query tree, I think. Um, can update this afterwards if this is not the correct way to do it, but let's do it like this. And let's get the name here, query tree. So now we have the root node. We just need to check first if root is nil, then we just need to return nil. That's the first check we need to do. So now the thing we're going to do is we're going to loop through. I think we need to check if the key is the one we are searching for first. Let's check that. If yeah, I think we need to. The problem is that if I query like this, If I say YouTube dot total views, right, then we need to make the query in parts, and then we have to query that. So what I'm saying is, let's so I have to break this query into parts, like first part is YouTube and the second part is total views. And then I have to maintain an index here, which is the current part I'm searching for. And then I have to again, like if I found YouTube in the current root node, then I'll go to the next index and I'll search for total views in the tree, the current tree, in the subtree. So for that, I think I need, instead of the entire query, I need query parts and the index. So for that in parser, we need to break that in query, break that with the strings dot split. We'll break a dot. The only problem is that put here 0 is the starting index. The only problem is that if the key has a dot in it, this will break, because if the key has a dot here, this is going to take it as another query part, and it's going to just query the u first, which is not what we're looking for. We should query for u.u. So that breaks, but I think that's an edge case I will fix later. For now, I think I'll just go with it. So what do we need to check now? We need to just check if the root dot key matches with query parts of index. Then I'll return the root dot value. And I think there's also another you say edge case. If the index is greater than or equal to the len of query parts, then as well I'll return nil. Let's see if it works, but if the root itself matches, then it's fine. Otherwise, we're going to do the same walk algorithm, which is we're going to go through the roots run, and we are going to see if the root, if the child or key matches the query parts of index, then we're going to return child or value. I don't know if it's going to work, but let's query this. I don't know if it worked. Print it. Let's go to print it. So we are getting too many things which we don't need. Um, let's first search for the basic one, which is name. Nil. So there's something going on here. Let's print the root dot key wherever we are going. There's no key. I think it should be there. What is the problem? So, and now I'm getting the name, but not very deterministic, right? Changing. So if I go for something else, like previously total views, get the entire map. I think that's because it's sending the entire YouTube. Okay. I think we are not. Need to return root dot value, I guess. And if it matches, we are going to return query tree, but the root node is going to be the child node. Query part is going to be the same, idx plus 1. It's giving nil. No, let's try with the name. Okay, I get the name. Yeah, I think the problem with this is we're not populating the parent, I guess. Because if you see this, uh, the the one way we are walking, it's in parser. So if I do just this, um, yeah, we don't have any parent here. Let's also print the parent, maybe. So I don't see any parent. So the reason which why I'm going after the parent is that, so for example, if you are entitled, right, you need to keep track of your parents, like the videos and the YouTube, so that when querying, you know whom you are doing that. So right now, the name and country, they are of the root node, like they are of the base root node, so that works. Even the YouTube works, and that's why it's written the entire this thing, entire JSON as a map. But if I'm asking for video count, I need 50, not the entire JSON here. And for that, I think we need to check the parent. I mean, we need to store the parent. First, let's see if we can store that. So the new node's parent will be the root node, say the root dot key. Same here as well. Try walking now. Don't see parent. It's a string. And if I try to walk, um, should work usually. Let's try this separate now. Parent is null, like it's an it's string everywhere. Um, what can we do to populate that? It doesn't work that good. So let's. What am I missing here? Maybe we do that. That doesn't work either. Hmm. So why is it even not taking the parent? There is no parent or what? Because there should be a parent, right? Which is a root node. Maybe we are calling the root recursively, right? Maybe that's the problem as well. In order to get to this point, I need to update the root. So the we do for children of that, but we are just building. We don't know who the children. So for every this thing, right? We go with this. It goes into this case again. Again, this case. We have two children, and now for the third one, we try here. So the key, um, the value is this, but the yeah, okay, root dot children maybe. Okay, still the root is this. For this, you go here again. We try to call the build tree, but with the same root. But the root should be something different, right? What if it is a new node? Yeah, I think I can see the parent now. I remove this. You can see the parent here. So total views and view count is under parent. Videos is under YouTube. Um, so what about title and created it? So there's this. Okay, I think when we're querying, right, if we can check for child's key or child dot parent is query parts of index, right? And now if we try to query this, I think we get the answer. But before that, I just need to remove the walk method. Yeah, I get the answer, but we need to check for YouTube dot video count. Yeah, now we get the answer. But if I go for videos of 0, that I think that's going to be a problem. Of 0. If I do videos, yeah, I get this map, but I need to do with zeros like this. I can do this. But I think that should be passed from the tree itself, like when we're handling this, right? Instead of returning this, I need to do, like if I want to be able to do this, 0 dot title. So that I need to get title 1 here instead of nil. But that doesn't work because we are not passing this of 0 here. So we can check here. which root dot value dot type map of string of with map of string of any. So by default we can just return the roots value. So let's just print it list. What is this type? What's it? Shows a list of map. Is map to string of any, I guess. Okay, first I need to this. You need to do this. Of interface. I think it's not matching the YouTube and in the type it's going to be a string of interface. Yeah, I think it works for the YouTube, but we are inside videos, so maybe we can do that here. Finding that, I think we can do this. So we can try doing this. Oh, I think it's an array of interface. So we can do a switch on this. Do dot type. Default case is going to be, we can just return q. 3 and for case any. Yeah. Now we have identified that we have this. So in the query now we need to check like this. Can I do query parts of it? We're getting an error. Okay. Um, so the tricky part is to do this. Like maybe we can do this, right? Zero dot title. This is much better. But the problem is we can even have that here, like this. We need to have an idiomatic solution which covers all the edge cases and must be simple enough. So if it's a list of an interface, um, firstly the user must be able to do this like this, and we should not be able to search for. We should be able to identify if this is a key or if we are searching for the first index, right? Let's see how they do this. Don't know if they have. There might be some other way they might have done that, but I don't know where they give support for lists or arrays. Showing the like the examples. JSON. They are even doing the unmarshal thing. But we need is I don't know how they're going to do that. We have to search for that. But I don't think this is very simple to implement because the user can take this right and then he can convert that. But for querying, I'm not sure. We need to. Can we do this? But still, this can be the key itself. Very complicated one. That's fine. Let's go for the watch feature and then we can come back to this. For now, I'm not doing that because it seems too complicated due to the reason that I can even have this here, right? Then I have to, sorry, drop here, and if I put it here like this, then I have to do this in order to get the first index. And to parse this itself, it's an easy thing, I think. You have to match the key and the query. So the query is query parts of index, right? So that this is a query, and then what we have is child dot parent, for example. So we need to, let's try printing that. I think they don't even match here. YouTube and child dot key, I guess. So we're going to check. Um, we're going to check the difference between, right? Difference between strings. Two strings. Need to compare them, and usually they will be equal. Like this should be equal. And if the difference between them is this, I think should we do that manually? Do that manually. Let's do that manually. Yeah, one S2, S1, S2, both are strings. I'm going to, well, it is going to be an empty string. We'll just return the result before we do the calculations. So I think, can I do just a range in S1 to, yeah. So if I'm comparing two strings, if x equals s2 of I, can do that. How do I strings dot want at the index? S2 and the I. No. to do that. I have not done that actually. I can do that, right? It's true of I. Why can't I do that? But this comes as a byte. It's not equal, then I'm going to do that. Um, so just if it's equal, then I do continue. If it's not being equal, then maybe need to add the result. Add it to the result. Add to the result. Just add as to. So let's do check diff of that's working as we expected. So there is, if let's assume there is videos of 0 of 0, videos of 0. This is S1, this is S2, right? We go until they're equal, we don't do anything. If once they're not equal, then it should be this. I think if they're not, just need the higher length. If of S1 is greater than S2, this equals to S2 as but then what? Usually the S1 is going to be the bigger one. Do this. And is getting much complicated than I think. So let's just ignore for now because we want to focus on the watch feature of the file. Should we watch a file? How do we watch that? So, so let's check their code.mod, see what they use. If we go for providers, how do they watch this thing? Because if you see, they have this watch thing which is try to provide a, let's see, provide a, yeah, they're using FS Notify. Let's go there. So FS Notify go. Get a new watcher and then start listening. Where do we give the file name again? Yeah. So create a new watcher.go. We go here again, we need a package type, it's going to be watcher. The path to be watched, and he asks for new watcher with the path to return a new watcher. I think this is good. So when you're creating a new watcher, right? I think we need a watch object. If you try to do this, the type of this is going to be a first notified watcher, right? So just handle that. And first notified watcher. Let's keep this internal because I don't think we need to return that. But and now I can do watcher watch where I do have this to defer this close. Maybe we can have a close method here itself. This cleans up the um, we have to start listening for events like this, and we need that to be in here, I guess. So watcher, yeah, I think that works. So for watching, we already have the FS Notify object. We need to add the path here. So we'll just do FS Notify dot add the path. So whenever we get an event, yes, we should be able to that. Okay. If I do YouTube dot total views, getting the right. Yeah. So now I can do. Okay, we need to add the interface to the parser. Just query, but also watch. The path. Okay. Just say no watcher the path. So we can actually call a function on the watch. Yes. What I mean is instead of um, we can have function here, let's say. Um, and we can call that. So the way we use it is that we give a function here. Just for now, let's print it has been modified. That's one we want to watch. So we need to print that here. Let's do this data.json. But we need to block it, right? Until we how do we block that? Yeah. So here is the blocking part. So why do we need this? Because in order to watch it, you need to be continuously running like a server, and then you can be able to do that. Um, put it here. Let's see if I modify this to, and we got this event here. Rename this, right? And when we get this, let's wait. So actually, our function have to be called. I don't know. We don't. Why don't we have that? Okay, it's not a write, so not a write call. So that's the reason it's not doing that. But how do you know if it's maybe if we add something else, right? Like let's say banner image. That should be the right call, but yeah, now we see that the file has been modified here. But why does it show rename? I guess when we update it like this, the second time it's not showing. Okay, is it because of this? Is it because of this before? I go here. That's the rename. Not because of the. I think that's fine. So um when we have this right in parser, when we are watching this and this file has been modified, what we want to do is we want to load everything again. We want to parse it completely so that we can test that by we have a file here. First, let's add a query here. I think the total views has come here. So now I'll add something which is not in the JSON. Name, country, I think. total time spent, something I just don't know. So it's 1,000. So what I want to do is I want to watch and then query as well. But okay. So if I check it by querying, query. So remember that this only calls when the file has been modified. So let's cancel this, move this, start this. And if I go here and add a query that, wait, just cancel this. I only want to add a query for total time spent. So this should return 1,000, I guess. But that isn't in this JSON right now. So first, then I would add this here. If I reload this, am I not getting this? Maybe we need to create a new parser. Yeah, that's why we are reading the. Yeah, we need to create a new parser. So for that, I think let's do this. So I'll again remove this, all this. Still, it's showing null. I think that's might be some PP here. And again, remove this, done, and getting that. Should be getting that. We're still getting nil here itself. Total time spent. So we're getting that for name as well. We did something to the query part that it's not giving us this. What did we do? Yeah, now I'm getting. Is it so random? So let's try this again. Go here, this, back. I think there's some undeterministic thing that's happening with uh, the loading of this variable. I don't know what's that, but yes, that's fine because if I remove something here, I'm not getting that. So let's try something else. Wait, what happens if I split this into? Total time spent. and this is fine. There are three children. Okay, this is not being loaded. The reason, what's the reason? Is this being called before we are modifying this? So if we take this, right? We take this and put it here. This. Will that work? Yeah, that works. I think this function is being called, not called, it's being loaded before it's before we are even calling it. So now that you see, now what I did was that I deleted this. Like I don't have this line, and I started the parser, right? Started this like this. Now if I query this, so now I don't have the total time spent key here. So I'm trying to query that here. So if we query this right now, we get a nil here. But after loading this, if I try to do that, I'm getting a null. We're getting now we got a null. But we got that previously, right? Yeah, as I said, there's some undeterministic thing happening. I don't know what's that exactly. But still, I think we got a working version here. That's what I wanted to do. So a couple of things which I could improve is one is a list access on query, like via query, and the second one is undeterministic results. Hope this is non-deterministic. I think yeah, we got a decent working parser. I think this should be good for us. But the query part is cool, but still we have something to improve upon, which is, so we basically built a tree, and on top of that we are doing the query. The tree is great, but we need a way to identify that as a list and then query on top of that. For that, I think maybe we think for that maybe we need some extra um, values inside the node struct. For example, type of this node, the node type should work, right? And let's say it's a string, but if the type is of list, then we need to break it into parts, right? It's going to be a list of any, I guess. So as I said, we could do something like this, but again, mm, just trying to see if that's the solution. Like this should be done when we are building this. So when we are putting out children and we are checking for this, we have to check for the value. I think it comes into default. We have to check for the list of any when we are building. And for parts, we just have to store the parts like like how we did for this. Like we can do, we can, if I do the, if I do that here, so this is there. So we can check if I think we have to do a switch anyhow. New node. So we can check v dot. We can just put it here. It'll be the same, but I guess we need to take the parts out. If it's an interface, list of interface, it is most probably a string of any that thing only. The parts is going to be true for this INV. So we need to do that in range. This is going to be an interface. Yeah. And we need to map this to map string of any, and we need to store that in our node, which is new node dot paths equals to append the path, right? um, I think that's again going to be in the map, but still, if we have the parts, right, we just need the values, I guess. um, we need the value and this, but okay, let's say node part list, right? Have a key which is a string, value which is any for now. And we are going to do that node listed part. Key is going to be um, we need to map through this, right? And that for each part. So this is a list of interface. Yeah, so it's list of maps, right, of keys and values. So if we do this, I do I here, remove the V. Here we have this each map coming in. If I map this like this, and if I do part, but if I map that to no. So yeah, I think this is parts for key and value and key value and range of parts. We can print the key and value. We get this everything here, but we need to map that to. So this is the zeroth. Yeah, I think we can just add that like this. Key is going to be the key and value is going to be the value. Right. If we have like this, now we have. So if I do no dot r, see have this still I think they don't go into the index properly. I think it's still hard to get that because cannot do this for now because this can be in the key itself. So we need to find the difference. So yes, I'll just ignore that for now. But that is definitely the first thing if I have to improve on this. But we got a basic parser running. Um, I think that's it for today's video, guys. Thank you for watching, and I hope you like this new format. And let me know what you think of this. Okay. Thank you, guys, and see you in the next video. Bye.